Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about operation on one random variable. And what is operation on one random variable? The random variable is used as a mathematical tool for describing the characteristics of some real phenomena and physical random phenomena. Some important statistical properties that may be performed on random variable. So that statistical properties or statistical operation properties are expectation, movement, variance, etc. So these expectation, movements, variance include the statistical operations. And the first topic in operation on one random variable is mathematical expectation. So what is mathematical expectation? The averaging process when applied to a random variable is called the expectation. An important concept in statistics is the mathematical expectation or simply expectation of a random variable. Consider a discrete random variable X. The discrete random variable X taking the values or the values of the random variable small x1, x2, x3 and so on xn with probabilities probability of x is equal probability of x is equal to xi for I is equal 1, 2, 3 and so on N. Then the expectation of the discrete random variable X is given by expectation of x is equal to sigma I is equal 1 to N xi into p of xi. So capital X is the random variable. For discrete type, the expectation of the random variable is given by defined as expectation of x is equal to sigma I is equal to 1 to N xi into p of xi. So p of xi is the probability of the random variable with values. And what are that values? x1, x2, x3 and so on xn. So now here expectation of x is also referred to as a expected value of x or average value of x, and it is also denoted by the expected value of the random variable e of x is also denoted by or represented by small m, mu or x bar. The expectation of the random variable is denoted by symbolically expectation of x or small m or mu or x bar, and this is the expression of the expectation of a discrete random variable. Expected value of a random is its probability weighted average if all the probabilities are same. So that is, if random variable X takes all the values x1, x2, x3 and so on x suffix n with equal probability. So then expectation of x is equal x1 plus x2 plus x3 and so on x suffix n divided by N. So this equation is the arithmetic mean of x1, x2, x3 and so on xn. So now here this equation is the expectation of a random variable X with discrete type. So similarly, if the random variable X is a continuous random variable, the concept of average can be formulated in terms of integrals. Okay, if X is a continuous random variable, then the expectation of the continuous random variable is given by or defined as expectation of x is equal integral minus infinity to infinity x into fx of x dx. So fx of x is the probability density function of the continuous random variable X. Okay, so you now hear the mathematical expectation. So expectation of the random variable X for the continuous case and the discrete case. For the continuous case, the expression can be formulated in terms of integrals. That is this one. So similarly, let us consider some real function. That real function is g, or g of x is the real function. The mathematical expectation of some real function g of the discrete random variable capital X is given by expectation of y. So the real function y is equal to g of x. For the discrete case, expectation of g of x is equal sigma I is equal to 1 to capital N g of xi into p of xi. This is the expression for the discrete random variable case. So similarly, for the continuous random variable case, g is the real function. The expectation of g of x is given by integral minus infinity to infinity g of x into fx of x dx, where g of x is the real function of the random variable, fx of x is the probability density function of the random variable. So this is the concept of mathematical expectation, or simply expectation. Next, we are going to discuss about properties of expectation. First property is, if the probability density function f of x or fx of x is the probability density function of the random variable capital X. The first property is, if the probability density function of a random variable capital X is symmetrical about a point A. So that is, fx of a minus x is equal to fx of a plus x. Then the expected value of the random variable is A. F of x is the density function. That density function is symmetrical about the vertical axis, about the point. So that point is small a. So this is the condition. Then the expectation of the random variable is small a. And second property, if the probability density function of a random variable capital X is an even function, that is, f of minus x is equal to f of x, then expected value of the random variable is 0. So the probability density function is denoted by simply f of x or fx of x, and this is the second property. And third property, the expectation of any given linear function of random variable capital X is equal to the sum of the linear function of the expectation of x. For example, expectation of ax plus b is equal to a expectation of x plus b, where small a and small b are the constant. Okay, expectation of linear function of the random variables is equal to the sum of the linear function of the expectation of x. Next, fourth property is, the mathematical expectation of the sum of the random variables is equal to the sum of their expectation. Sum of their expectations. So provided all the expectations exist. Suppose, for example, if capital X, capital Y, capital Z, and so on capital T are capital N number of random variables, then the expectation of sum of random variables is equal to sum of their individual expectation. So that is expectation of x plus y plus z plus and so on plus capital T is equal expectation of x plus expectation of y plus and so on expectation of t. Next property is, the mathematical expectation of the product of a number of independent random variable is equal to the product of their individual expectations, provided all the expectations exist. For example, if capital X, capital Y, capital Z, and so on capital T are n number of independent random variables, then the expectation of product of random variables, all the random variables are independent. So expectation of product of random variables is equal to product of their individual expectations. That is expectation of x, y, z, and so on capital T is equal expectation of x into expectation of y into and so on expectation of t. So these are the some important properties of expectation.